Okay, so we're back now with question 9, and question 9 is a compound interest rate question, 2.4% compound interest. Immediately I see 2.4% compound interest, think it's going up by 2.4%, and that's equal to multiply by 1.024. It's the first thing I think when I see up by 2.4. Important to know that. Right, now, with numbers like that, I'm going to expect that this is going to need a calculator. The whole test so far could have done pretty much everything without a calculator. There were some pretty horrible numbers in question 4, but you could have got away, but you're going to need your calculator for this. Let's open that up. Okay. 4,000 invested after n full years. Okay, so let's just put a little diagram for this. 4,000 after 1 year, it's going to be times 1.024. It becomes whatever you've got here. This is year 1. This is year 0. Okay. Then we're going to times 1.024 and we'll get the year 2 value. Now, we start with year 0 with compound interest. Because of that, you have to be careful with your formula because it's not exactly the same as geometric progression. So after n full years, you're going to have multiplied by 1.024 n times, because after 2 years, you've multiplied it by 1.024 twice. So 4,000 times 1.024 to the power of n. Now, in a regular geometric series, we've got, you'll have an n minus 1 there. So that's why this is a little trickier. Okay, so that's my expression. Now, the next thing is asking for, and it just says write down, so they don't care for any method on that. What will the value of the investment be at the end of 6 years? Okay, so then that's just putting some numbers into a calculator. So that's part A. Part B is 4,000 times 1.024 to the power of 6, and that's equal to, so we can bung that in. Right. 4,000 times 1.024. Now, the raised to the power is this one here. Raised to the power of 6. Is my calculator screen visible there? Let me just change the contrast. There. Bingo. Right, 4,000 times 1.024 to the power of 6. Enter 4611.68. So let me write that down. 4611.686. So, if I now think about that, that is in dollars, so I would want that to the nearest cent. Dollar 4611.69. Okay. You shouldn't really round finance numbers to 3 significant figures. Right, so just the contrast. There we go. Part C. Write down the inequality to represent this information. The value of the investment will exceed 8,000 after n full years. Okay, so after n years, it's going to exceed, so part C. 4,000 times 1.024 to the power of n after n years is going to be bigger than 8,000. Lovely. Well, that's part 1. That wasn't hard. Part 2, calculate the minimum value of n. Right, this is going to be tricky. The minimum value of n, we're going to have to use either a graph on our calculator, a bit of trial and error, or you can use a mixture and use a table on your calculator. And we might try all 3. Let's see how we go. So The minimum value of n to just cross that threshold. Let's simplify this. If we divide by size by 4,000, I've got 1.024 to the power of n is greater than 2. Okay, so if you knew about logarithms, you could solve that using logarithms, find an exact value for n and then round up. We don't know that, so a little bit of trial and error. Let's just pick a value. Let's put our calculator on screen there, and that's visible. Right, so I can do 1.024 to the power of, let's pick 5 and see. That's 1.12, we're nowhere near. I could just make a note. 1.024 to the power of 5 equals 1.12, no good. 1.024 raised to the power of 10. Still nowhere near. To the power of 10 equals 1.27, just showing my working. 1.024 raised to the power of, I don't know, 20. See how close we get. 1.6, we're still far away. 1.6124 to the power of 30. 1.024 to the power of sorry, that was 20, not 30, but let's do 30. 1.024 to the power of 30. 2.03. 30 equals 2.037. We've just gone over at 30 years. So let's just check 29. 1.024 to the power of 29. 1.98. 1.024 to the power of 29 equals 1.99. Okay, so this is great. So actually what this tells us is that at 29 years it's not enough to get above 8,000. At 30 years it is. So we say yes, this one here, therefore 30 years. Because we were trying to solve this for 2, but just to be, just to be a little bit extra, we can put it back into the original and say 4,000 times 1.024 to the power of 29 equals 4,000 times 1.024 to the power of 30 equals, and let's do that, 4,000 times 1.024 to the power of 29, and we've got 7,957 dollars dot, and if I replay that second function, if I want to replay that, just do that entry and change that to 30. Okay, if you missed that trick, that was this blue entry. Oh, I can't see that on screen. I did second function entry, and I got the previous one up on the calculator. So that's $8148, and it shows that we are in between. So 34 years, done. Happy days. I think that was the easiest way to do it. But what we can do is we can show this as a graph. I'll make the screen a bit clearer. Okay, so if we were to do this as a graph, and I would do y equals, let's clear those, okay, 1.024 to the power of x. Now I'm going to subtract this 2 and find out when it's greater than 0. Minus 2, now let me just write that here, I'll do it in red. 1.024 to the power of x minus 2 is greater than 0. So I've plotted y equals this. Okay. Can't really see what I wrote in red there. There it is, 1.024. That's the equation I'm doing. Okay, let's bring the calculator back up. Right, it's greater than 2. So if I graph that, it's not going to give me much. My axes, that's the problem. My axis, my window is way off, so I'm just going to do zoom 6 zoom standard, because I've been using the calculator before, and now I can see what's going on. So this is from -10 to about 10, I think, and it's not reached, it's not crossed. So I'm going to change my window. I only want the y to go between -1 and 1, really. And my x, I don't need negatives. I can say from 0 to 50 and see what happens. Now I graph that, and here we go. And it's going to cross somewhere. Okay, so I've seen that cross. So I'm going to hit the zoom. I'm going to zoom a box now. I've got something sensible. And there's my box. It's going to appear. So get your first coordinate, get your second one, and hit your box. There you go. Right, so I can see it crossing there. I need to know what these values are. So if I get my little cross here, it's saying I'm at 29 point something. The value here is 30. That's 30.01. So I know that it's 30, and that's how you do it with the graphing on the calculator. Final approach using a calculator, going back to your original method of getting these values here. Okay, so we can use a table for this. Using a table, second function, we want to do a list really, so hit stat and then go to edit. So let's just clear that. Let's quit this and clear. Alright, so you do stat and you get this screen, and you go 1 to edit, and you want to edit your lists. Now my lists are fortunately empty, so I'm going to put in some values here. 1, 2, 3, just to give me some values, and I'm going to say list 2. I'm going to move up into list 2 there, and I always put these speech marks because just in case I need to edit it afterwards. Speech mark, and I'm going to do 1.024 raised to the power of list 1. I want list 1. And list 1 is down here, list 1 in blue. Second function, list 1. There it is. 1.024 raised to the power of list 1. Close speech marks. Enter. Right, now it's done those 1, 2, and 3. Now I can see, oh look, I can see the values. And what did I have? I had 5 here, didn't I? About 5, 1.12. Let's see, let's put a 5 in there. Great. 10. No, 20. These are the same values I got. 30. Yep, okay, 29. Yeah, that's what I did, and that's how you do it using a list. It's quicker, isn't it? Okay, I think that's probably the best method. Right, all done. Thank you very much.